All right, welcome back to the continuing saga of ELM Prep. This is part 2 of percent increase and decrease. So let's talk a little bit about the idea of a percent increase in general terms. So we want to know the difference from point A to point B. So we'll say the current amount minus the original amount, whatever that was. So we want to know the percent change, or the amount of change. The amount of change that we have. And then we're going to divide by the original amount. So this will give us the percent increase or decrease, as it may be. If this were a negative, then it would end up being a decrease. So let's say last term we had 30 students in our Math 50 class, and this year we have 32 students, or this term we have 32 students in our Math 50 class. Well, we might want to know what the percent increase is here. So we want to know our change. So we're going to take the current, 32, minus the original, divided by the original amount. Well, this then becomes 2 over 30, or 1/15. So our percent increase, if we put that in terms of a decimal, we could probably find the percent increase. So whatever that percent is, that's our percent increase. Well, what if we only had 28 students this term? Well, obviously, we have fewer students, so we have a decrease here. So let's see what happens if we use our general formula again. We took the current amount minus the original amount all over the original. Well, we end up with minus 2 over 30, or minus 1/15. Now, the negative implies a decrease. So this is a percent decrease. So the negative in terms of this formula indicates a decrease, or a percent decrease. All right. Okay, so we have a parking lot, and in our parking lot, the average number last term was 150 cars. And this term, it averages 155 cars. Well, obviously, we've increased the number of cars on average. So if we were looking at a percent here, it would obviously be a percent increase. That implies that our answer is going to be positive. So we take the current value, 155, minus the original value, 150, all over the original value, 150. Well, the difference between 155 and 150 is 5. So now our percent increase, albeit very small, is a positive number. And we would then have, if I'd reduce that down, 1/30. Not a very big increase, not a very big percentage. Okay. But the general formula holds true on this. If we're looking at percent increase or decrease, we're going to take the current value minus the original, and then divide by the original to get percent increase or decrease, depending on whether it's positive or negative. All right. This is a common problem that you might come across in your ELM test. Okay, let's talk about reading charts in terms of percent. they might want to know what percent of the total A and B is. Well, if this looks like a straight line across here, then A plus B would be half the circle. So A plus B would be 50% of the total. Well, that's fairly straight. That's not too bad. But what if they want to know what B plus C is? Well, obviously that's not half of the circle. But it is more than 1/4 of the circle here, plus a quarter. So, but it's less than half, so it's a quarter plus maybe a half of a. So this is 1/4. This is maybe 1/8. 1/4 plus 1/8. And so this would be 2/8 plus 1/8, or 3/8. And then we could convert that to a decimal. So B plus C would be 3/8 of the whole as an approximate number. Now we're just guessing because they haven't given us any values. So this is a guesswork problem. So you want to take your best guess based on the sizes relative to each other. Well, if we just wanted to know what D was, let's look at D. It almost looks like a fourth here, that this might be perpendicular. If it looks like it's perpendicular, you could take a guess that D was approximately 25% of the total, because it's 1/4 of the circle. If I were to add A plus D, well, there's half of it. We know it's more than half, but it's not 3/4. So here again, I have 1/2 plus, maybe half of a quarter. So that's an 1/8. So this would be 4/8 plus 1/8 for a total of 5/8 of the total. So A plus B would be 5/8 of it. Well, it sort of goes along with our estimate here of 3/8. When we put them together, we get 8/8 for 100%. So percent estimation comes in a lot of different kind of problems, and they like that circle estimate kind of thing. They may even give you percentages on these things. They might break this up into amounts like that and say, well, this is 25% and this is 30. Well, we might go a little higher than that. No, I'm sorry. Yeah, 25%. And this might be 15%. And this might be a little less than 50%, maybe 48%. And then that would leave us some amount there. And then they might ask you, well, and they might label this as supplies and overhead and maintenance and something like that. And then they would ask you, well, what's the combination? And I'll just say miscellaneous. They might ask you what the combination of overhead, supplies, and miscellaneous are. And so I'd add these around and then find out what this amount was and then add them all up. Well, it's obviously just a little more than 50% because this is just a little bit bigger. 25, that's 40% there, and this is 48. So this is going to be a little more than half because this is 48%. All right, so we quickly ran out of time on that, but hopefully you were able to get a better idea of how to use percents in terms of what we call pie charts, where we break the pie up into pieces and we ask you to estimate what those pieces are. A lot of these questions are estimate kind of problems, and we'll talk a little more about those with different kind of problems. Anyway, hope that was a little informative. Please come back. Thank you. Have a good day.